So now we are going to deal with one of the most interesting part, that is bonding in metal carbonyls. We are mainly choosing this as one of the greatest topic because as we know that complexes means the central metal atom is bonded to a ligand. But here what is happening means a special type of a bonding is formed when you are considering a complex in which your carbon monoxide is acting as a ligand. Now we are going to see that what is that special type of a bonding under the topic called as bonding in metal carbonyls. So if I just choose, this is my metal, okay, a central metal atom on here. If I choose its orbitals is in this way. Okay, this is my central metal atom. Basically, the bonding with the metal carbon is explained with respect to the molecular orbital theory. So this is being connected with that of your carbonyl. Of course, see triple bond O. Oxygen is also having their individual orbitals. Even our carbon is having our individual orbitals. So what first is happening when this carbon monoxide is acting as a ligand? First, it takes place the bonding which is taking place. We have to remember that the electrons which is present, the electrons which is present in the ligand, okay, the electrons which are present in the ligand is first overlapping with respect to the vacant d orbitals of your central metal atom or the ion, okay, leading to the formation of your sigma bond. So in simple terms, we are taking place that ligand to metal bonding which is taking place in your metal carbonyls results in sigma bond, and this is also a coordinate bond. It is actually a coordinate bond, but it doesn't stop over there. In turn, what happens? The electrons which are present in now the d orbitals of your central metal atom or the ion, it is now overlapping with that of your pi star. We can say, if you are remembering, we were dealing with this star and without star, sigma, sigma star, pi, pi star. That is called as what? Anti-bonding molecular orbitals. So second type of bonding is observed from metal to ligand. Metal to ligand, that is the vacant, that is the d orbitals, filled d orbitals of your central metal atom or the ion is overlapping with that of your anti-bonding, vacant anti-bonding orbitals of your carbonyl, or acting of which is acting as a ligand over here, which is resulting in the pi bond. But you have to keep in your mind that here such two pi bonds are observed. That is, when the bonding is taking place with respect to ligand to metal, okay, the transfer of the electrons is taking place from ligand to metal is results in the formation of your sigma bond. But when the resulting taking place from metal to ligand, that is resulting in a pi bond, which is called as that of your back bonding. And due to this back bonding, what happens? It strengthens the bond between your metal and the ligand, which is not observed in other type of the complexes. And this type of 1 sigma bond and 2 pi bonds is mainly one of the most important properties what we are observing in that of your metal carbonyls. So this is a special type of the bonding which one has to know. When carbon monoxide acts as a ligand, there is a formation of a 1 sigma bond and a 2 pi bonds. So sigma bond is formed when the ligand is transferring the electrons to that of your vacant d orbitals of your central metal atom or the ion. Whereas the pi bond is resulting when the filled d orbitals of your central metal atom or the ion is donating its electrons to the anti-bonding. Remember, they are anti-bonding orbitals of your ligand, resulting in the 2 pi bonds. So this is the major important thing one has to know when you're dealing with that of your bonding in metal carbonyls. The greatest example, of course, we have dealt with it, a neutral complex of NiCO4. There are many such compounds, you can just refer to your textbook, but now the most important thing which we have aware of is called what you can say is tetracarbonyl nickel zero complex. So whenever you are having a carbonyl complex, such type of a bonding is existing. Very much important with your competitive exams also, because they may ask you that what type of a bonding can exist with respect to bonding in metal carbonyls.